All right, so let's check out practice 5.4. And they're just giving us a point. So we have the ordered pair. And of course, they're giving us the x and y of our right triangle. And they actually give a picture for us also. And so now we're just going to go through, and this is really going to be on what you've memorized. Now, again, if you look at the picture here, they're telling us that the initial leg is going to 1. So this is a radius 1 unit circle. So instead of dealing with y over r for sine, we're just dealing with y because r is 1. And so we can just immediately identify that. And cosine, we'll know, is x over r, but r in this case is 1. And so we can identify then cosine. Tangent, y over x. And if we look at here, we have y over x. And then the other three are just the reciprocals of these. So I'm just looking at the other three and flipping those fractions. All right, so just entering the last one in there, make sure I get all the questions. And there it is, just the 6 trig functions for that first one. And here we have the unit circle of angles here to help us do this problem. Again, it's up to you if that's what you want to use. Nothing wrong with using that. But we're looking for sine of 5 pi over 3. Now we can just look at the circle that they've given us, or we can use reference angles. So again, a good point to look at is pi, because this is an easy fraction to take care of. We needed a common denominator of 3, so we can just multiply this by 3 over 3. And so we can see that this angle is definitely in quadrant 3 or 4, since 5 is going to be greater than 3 here. Now, the next thing we'd have to really check here is, here's 3 pi over 2. And now we are needing to get a common denominator here to determine if this is in quadrant 3 or 4. So to do that, we'll multiply this by 3. And we'll multiply this one by 2. And so we can see 10 pi over 6, 9 pi over 6, which means this is just in quadrant 4. So there's our angle. And so what we're looking for right here then, the reference angle. So the reference angle then, since this is 2 pi, with the left over here would be 2 pi minus 5 pi over 3 for our reference angle. And we'd have to get a common denominator again. So 6 pi over 3 minus 5 pi over 3 to get us pi over 3 as our reference angle. So we're going to look then at sine pi over 3. So pi over 3 being the 60 degrees one, square root of 3 over 2. And then we'll look back at our reference angle. Now our reference angle has a positive x component and a negative y component. And we know sine is y over r. So we can see sine, the actual angle, 5 pi over 3, is going to be this number, but the y is going to be negative. And so we know our final answer here is going to be minus square square root of 3 over 2. All right, well, sometimes MyMathLab will take the square root notation. Sometimes it won't. Let me try that again. Use the square root 3 symbol. And there we go. Next question. We got another unit circle here. Looking for the tangent function. And again, you just want to look at the circle, the unit circle there on the right in MyMathLab. You can use that to get the answer. But of course, this is trig, so it's always good to learn how to get these angles. So a good starting point, looking at pi. We see our fraction has a denominator of 3, so we'll make this 3 over 3. And now we can see 2 pi over 3 is in quadrant 1 or 2. So the next question is to compare it to pi over 2. So we'll need to get a common denominator here. And a common denominator for 2 pi over 3 means we'll have to multiply by 2 over 2. And so we can see 4 pi over 6 greater than 3 pi over 6. And so here is our angle, 2 pi over 3. And then what is our reference angle? Well, that's going to be 3 pi over 3, because that's the 180 degrees there, minus our angle, which is 2 pi over 3, to get us pi over 3. And we're looking for tangent. And so this is sine over cosine. And sine pi over 3 is, we just did actually, square root of 3 over 2. And cosine pi over 3 is a half. And that gives us a square root of 3. Now, tangent is also y over x. So if we go back and we look at our angle in quadrant 2, we can see it has a negative x position and a positive y position. And in positive and negative means our final answer for tangent of 2 pi over 3 will then be negative square root of 3, since we have a negative component right here. Let's check out the next one. We got another angle, secant pi over 3. Now, pi over 3 is already one of the angles we should memorize, so there's no reference angle here at all. So secant is 1 over cosine. And cosine pi over 3 is a half. And so taking the reciprocal of this complex fraction, we get 2. And that's our answer. Cosine, didn't we do cosine pi? 5 pi over 3? No, we did sine pi over 3. All right. Let's check out cosine 5 pi over 3. So pi, 180 degrees, 3 pi over 3, looking at the common denominator here for these fractions. So we can see 5 pi over 3 is in quadrant 3 or 4. And so we'd have to check this again. Getting a common denominator, so we have the 3 over here, 2 down here. We'll have to multiply this by 3. And multiply this one by 2. So we can see 10 greater than 9, which means 5 pi over 3 is in quadrant 4. And we need to figure out what this reference angle is. So that's going to be 2 pi minus our angle. And we would have to get a common denominator here again. And so our reference angle is pi over 3. And we're being asked for cosine. And cosine pi over 3 is a half. Now we're going to look back at our reference angle picture. So we have a positive x direction, but we have a negative y direction. So if we look, cosine is x over r. R is always positive. So the question is does x change sign? And it doesn't. X is in a positive direction for 5 pi over 3, which means it's going to have the same sign as the reference angle. So 1/2. Oh, there's another part to this one, it looks like. Minus 5 pi over 3. So just to go back to the previous picture we had, so minus 5 pi over 3 means instead of rotating counterclockwise, we're going to rotate clockwise 5 pi over 3, which will then give us this reference angle, which again we know, because we just did this problem, is pi over 3. And if we look at this reference angle, we have a positive x and a positive y, which means there's going to be no change in the sign of our reference angle. It's still going to be a half, because x is positive, y is positive. There's going to be no change in our sign, even for minus 5 pi over 3. Now, another way to look at this is that cosine is an even function. And remember, an even function means if you plug in the negative angle, that's exactly the same as plugging in that positive angle. So that's what an even function means. So we could have just answered with the statement right here that cosine is an even function. And so it's going to have the same value as the one we just did. So here's the next one. Sine 5 pi over 4. So as always, check out what quadrant this angle's in. Pi with the common denominator there. So we see 5 pi over 4 must be in quadrant 3 or 4. So we'll have to compare to 3 pi over 2 here. And to get a common denominator, we'll multiply this by 2. To get a common denominator up here, we'll multiply this by nothing, because that's already 5 pi over 4. And we get a 6 pi over 4. So that means this angle's in quadrant 3. And so the question is, well, what is this reference angle? Well, we'll take the larger angle, which is 5 pi over 4, subtract off the 180 degree mark there, and we find the reference angle is pi over 4, which is 45 degrees. So we're looking for sine pi over 4, one of the ones to memorize there, square root of 2 over 2. Now we're going to look at a picture. So for our picture, we have a negative x direction and a negative y. So if we look at sine, we know sine is y over r. Now remember, for the reference angles, x, y, and r are always positive. So square root of 2 over 2 comes from a positive y over r. That's the reference angle. But if we look back at 5 pi over r, we actually see y is a minus for 5 pi over r. And so that's just going to switch the sign then of the reference angle answer. And so we'll get minus square root of 2 over 2. So they're giving us a 13 pi over 4 here. Just trying to quickly see what they're trying to do here. And 13 pi over 4, let me just get a new piece of paper for that. So 13 pi over 4. 13 getting to be a larger number. Once we start dealing with larger numbers, we're going to have to start considering the 2 pi then to see if there's a full revolution here. So converting this to the denominator means we'll have to multiply by 4. And we can see 13 is larger than 8, which means there's at least one full revolution here. So we go one full revolution of 8 pi over 4. So we're going one full revolution, and then that leaves 5 pi over 4 left over. And we just figured out 5 pi over 4 was in the third quadrant. And so there is our angle of 13 pi over 4. Now, if you look to the last problem we just did, (13 pi over 4) is coterminal with 5 pi over 4. Because both of these angles start and stop at the same position. So they're coterminal, and coterminal will always give the same answers. So 13 pi over 4 is coterminal with 5 pi over 4, which means they have the same answers then. They're representing the same initial and terminal sides. All right, tangent, pi over 4. Now, pi over 4 is one of the angles you should remember, so there's no reference angle here. So tangent is sine over cosine. Now, pi over 4 is the 45-degree one. That's the square root of 2 over 2, square root of 2 over 2, which is 1. And that's our answer. All right, so now we got 13 pi over 4. And we just did this angle too, didn't we? The last one. So 13 pi over 4 is 8 pi over 4, which is one full revolution, plus another 5 pi over 4, which is that angle again in the third quadrant. And this angle in this third quadrant, so this reference angle is what we're curious to know. And given our 180 degrees here, in terms of denominator 4, that's 4 pi over 4. We know this angle here is at 5 pi over 4, which means the reference angle then is pi over 4. And we just did tangent pi over 4. It's 1. Now remember, the reference angle are always dealing with positive x and positive y. The reference angle is always dealing with positive numbers. Now, if we look at our picture, though, you see we have a negative x and we have a negative y. Tangent is y over x. Now, in this case, they both happen to be negative, and so the negatives will cancel, and so it's just a straight y over x again, which means there's no sign change to the reference angle. And so our answer is 1. All right, so just have some substitution here. These are a little tests of your knowledge of even and odd functions. So first of all, if we look at what we have here, we have sine of minus t minus sine t. And if we look at the information given is telling us, well, sine positive t equals a. And then you want to recognize that sine is an odd function. And an odd function means the negative of your input is exactly the same as the negative of the output. And we can write that as minus a then, because we know sine of t is a. And so we can plug this in for our sine of minus t. So we'll get 5 then minus a. And sine of t we know is a. And so we'll have minus 6a. We got another one of these. So we have tangent. Now, we didn't go too much into tangent. The book doesn't either. But tangent is an odd function, because sine is odd, over an even function, which actually turns out to make tangent odd. So tangent is an odd function. And what does that mean? Well, that means tangent of negative the input is exactly the same as the negative of the output, with a positive t instead. So again, this is what it means to be an odd function. It's the definition of an odd function. And we're also told that tangent of t equals c. So if we look at the equation they give us, well, we know tangent of minus t is minus tangent. And so we can actually add these together now to get minus 4 tangent. And then the problem's telling us that tangent is c. And the last one, another one of these equation ones. I like these because there's just a little quick test of even and odd functions. So if we look in our equation, we have cosine of minus t. Now, cosine is an even function. Even functions mean the negative input is the same as the positive input. That's the definition of an even function. So when we have this equation here, we know we can rewrite this as positive t because it's an even function. So 10 minus 1 is 9. And they're telling us that cosine t is b by looking at the information they give us. And that's our answer. And there is practice 5.4.